I'm Annabella.
I'm Karina.
And this is our ear model. Okay, so first is the outer ear, and it's usually called the pinna or the auricle, and it's made up of skin and cartilage. And it consists of the tragus, helix, and the lobule, which are these parts of the ear. And the ear canal starts at the outer ear and ends at the eardrum. Next is the middle ear, which is the part of the ear between the eardrum and the oval window. So the eardrum and then the oval window is over here. And the middle ear will transmit sound from the outer ear to the inner ear, of course. And that consists of the ossicles, which are the malleus, incus, and the stapes. The oval window, of course, the round window, and then the eustachian tube. And then lastly, there's the inner ear. And the inner ear contains organs of the senses and hearing and equilibrium, like the balance. And that consists of the vestibule, the cochlea, and then the semicircular canals.
So the pinna and the auditory canal are part of the outer ear. The pinna is made up of rich cartilage covered by the skin. The sound funnels through the pinna into the external auditory canal, a short tube that ends at the eardrum. So the pinna is right here, located right here. And then next is the auditory canal. So after the pinna, the sound waves travel through the auditory canal into the eardrum. The function of the auditory canal is to transmit sound from the pinna to the eardrum.
Okay, so next is the tympanic membrane, or a lot of people know it as the eardrum, and it's right here. And this is a thin layer of tissue that receives sound vibrations from the outer ear and transmits it to the auditory ossicles, and the ossicles, of course, being the malleus, incus, and stapes. So this is the eardrum. Next are the ossicles, and the ossicles consist of the malleus, the incus, and the stapes. And these are the three tiniest bones in the body. And they form the coupling between the vibration of the eardrum and the forces that are exerted on the oval window of the inner ear. The oval window's over there.
So the oval window is right here, and is basically just the opening from the middle ear into the inner ear. So you can think about it as like a hallway.
Okay, so next is the cochlea. The cochlea is right there. So overall, what it does, it'll transform like the sound, and it'll convert it into an actual message for your brain. Like clinically, I guess, technically, it'll transform the vibrations of the cochlear liquids and associated structures, again, into a neural signal that will later go to the brain and be transmitted into an actual message or words. So after the cochlea, there's the cochlear nerve, and it's also known as the acoustic nerve, and it's the sensory nerve that transfers auditory information from the cochlea to the brain. So it goes hand in hand with what the cochlea does.
So the vestibule is located around there, and it is an important part of your inner ear. The vestibule's main function is to detect changes in gravity and linear acceleration. The vestibule nerve is located right next to the cochlear nerve, which is right here. And the vestibule nerve is responsible for both hearing and balance, and brings information from the inner ear to the brain. So it goes within what the vestibule does and carries out the rest of the function. A human sense of equilibrium and balance is determined by this nerve.
So next is the eustachian tube, and it's a canal or passageway that connects the middle ear to the nasopharynx. And what it does, it controls the pressure within the middle ear, so it'll make it equal with the pressure outside of the body, which is very important. This is the sensory hair cells, and those are responsible for hearing. And there are two types of different ones, which are inner hair cells and outer hair cells, which are found on the inner ear or on the outer ear. Okay, so just in general, the way that the ear works is that sound waves will enter the ear canal and make the eardrum vibrate. Again, this is the eardrum. After that, with the vibrations, this will move the ossicles, the malleus, incus, and the stapes in the middle ear. The last bone in the chain, the stapes, will knock on the membrane window of the cochlea and make the fluid in the cochlea move, and that's what it is. The cochlea contains fluid, and then the fluid movement will trigger a response in the hearing nerve, which again is the cochlear nerve or the vestibular nerve, and then that'll transmit a signal to the brain, which will interpret the message. So it'll tell you what you're hearing.
So our patient is a 24-year-old female with otosclerosis. Otosclerosis is a progressive, mild to moderate conductive hearing loss in both ears. It is when a bony ankylosis knits the bone of the middle ear to the stapes, preventing normal transmission of sound from the eardrum into the ear. So basically, what bony ankylosis is the union of the bones of a joint by a loss of articular cartilage, resulting in complete immobility.
So this otosclerosis is inherited. So that means that her parents probably have it, her grandparents, yeah. So symptoms for otosclerosis include hearing loss or ringing in the ears, and in rare cases vertigo occurs. And in order to improve her hearing or her condition, a hearing aid is recommended, and a hearing aid just amplifies your hearing so you can hear better. And then a stapedectomy. And what a stapedectomy is a surgical procedure which will happen in your middle ear to improve your hearing. Okay, so symptoms for autosclerosis. So symptoms for autosclerosis, obviously they include hearing loss or ringing in the ears. You know, when your ears ring, like when a phone rings, your ears will ring.